We will be in December in 4 days. Can you believe it? Are you blown away by that? Why am I up in the corner? Am I always up in the corner? Well, no, I don't like that one bit. Let's see if I can. Oh gosh. Okay, there. I'll get myself out of the way. Although that is a little bit weird, right? Okay. Hi. Hello. The normal page. Hang on. Let me stop my recording real quick. Pause. I don't have a lot to teach you today. Today is mostly going to be a work day. I have a big assignment for you, but something that I kind of glossed over last week. I want to make sure it gets hit hard today, and you'll get to practice it a bunch today. So mostly what I want to talk about today is the 28th. Our vertical and horizontal lines. If your assignment today seems a little obnoxiously long, it's okay. It'll go actually faster than you think. And the reason for the excessive practice is that I want to make sure within a couple of days that none of us ever get these backwards again, that we don't graph lines incorrectly. It should just be something that we're like 99.99% almost perfect at. So, you're used to this. This is what we talked about a lot last week. So say I gave you an equation like y equals -1/3 of x plus 2. You can tell right away that this is neither a horizontal nor a vertical line because it's got both x and y. So x and y playing off of each other together are what make lines that tilt. They're not straight across, they're not straight up and down. They're going to have some slopey, tilty to them. So like just a quick warm up, where would I start the graph for this? No, thank you for saying up to. Good job. Up to. And then what's the slope going to be? Mm-mm. Nope. 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 So the slope is -1/3. How do we interpret that? How do we make a graph out of that? It's negative, so we know it has to go like this, right? It has to go downhill. So let's get that out of the way first. How do you manipulate a slope of -1/3? Yeah, Croton? Nope. So clearly, the 5 days off, you guys ate a bunch of turkey and forgot how to do everything. So yay, let's practice. I wasn't anticipating a long discussion about this, but it's all good. Please remember that slope is defined as rise over run. What that means is you do your change in y over your change in x. Rise is how far up or down you go. Run is how far to the side you run. So perhaps I should ask you again now, how do you want to do a slope of -1/3? Now that's how we get the week started. That's it. I heard some threes and ones, and I heard some people saying like go left one and up three. And the one is not the sideways number. The one is what we go down, and then the three is what we go right. And if someone said that, I certainly did not hear you. We could also, if we wanted to, we could have conversely gone the other way. We could have left and gone up one for a rise of one, and then we could have come back to the left three, and we're still going to make the proper tilt of down one, right three. Okay, and then you would, of course, just make a line through those points. Good, let's practice that again. That took a little bit longer than I wanted it to, so let me erase a bunch of stuff and we'll practice another one. So what if I gave you y equals 2x minus 4? Where do we begin our journey at? At down 4, good. 1, 2, 3, 4. Place your first point always on the y-axis. And what's the slope this time? Right, and it doesn't look like a fraction, but you always in your mind should think, I want my slope to look like a fraction. That gives us a very literal set of directions. And now that we're all back from Thanksgiving break, we're not going to say anything like right 1. We know better, right? We're going to go up 2 first. That's your rise. And then from there, you can travel to the right 1. Up 2, right 1. Up 2, right 1. Up 2. Or conversely, back down into the left. But we know it has to be uphill because 2 is a positive number. And the ratio of the uppy-downy and the sidewaysy is 2 to 1. Good, good? Is this coming back to you? Okay, so again, not what I had intended to talk about today. You'll see a bunch of those in your assignment, so you'll have to obviously be good at graphing those. Those are oblique lines. They have, um, the same sort of process as how you go to your hooking point on the y-axis, and then you calculate your slope and manipulate it from there. All right, so what I wanted to talk about today are lines like this. It should catch your eye. It's unique in that, obviously, I'm not going to ask you dumb questions. If I said, what's weird, you'd say there's no X. And the fact that there's no X means it's one of our special types of lines. Levi, did I just see you raise your hand? Were you just stretching? You know how to graph this one? I'm sorry, I just thought I saw you raise your hand. I'm not trying to put you on the spot, bro. No? Go ahead, tell me what to do. Okay, so I'm going to go up 3. And then you want me to put a dot there? Okay. And then what do we do? Yes, you do. You graph a horizontal line straight across. And so one of the things I'm going to have you add into your notes today, really, really important, is that when you see an equation that only has the y, it actually goes sideways. And you're going to get these backwards. I said this last week. It's not a maybe. Eventually, you're going to want to go, why do I keep getting those backwards? And the reason the human brain wants to graph this the other way is because when you see a y, you think of the y-axis that looks like this. And y lines actually go backwards. And did we talk about this a little bit last week? These types of lines, did they come up? So we understand, I think, why this is. If you look at all these points on this graph that Levi told me to graph, he told me to graph a line that goes straight across like this. What do all those points have in common? What's one characteristic that they all have? They're all up 3. In other words, they all have a y coordinate of 3. To get to any of those red points, you have to do something up 3, something up 3, something up 3, which is why a line like that is y equals just a number. Okay? Good, good. So the other side of this today is equations that look like this. Remember these ones? Again, this has to go up your radar pings, and you're like, wait a second, you're a weird one. You do not look like that hooking point, go up 1, right 2, up 1. You're not a normal line like we're used to graphing. How do we approach something like this? Say it again. We actually don't go down 2. And that's usually what you would say is because that's like what I've always told you is to start like that. But in this case, say it again. We actually start by going left 2. And I'll show you why here in a second. So if I graph a point at left 2 right here, boink, what kind of line is this going to be? A vertical line. Very good. So I'm going to graph the equation, and it's going to actually look like this. And my sales pitch to you again, and I understand completely that this may not stick until you're ready to have it stick, is that if I highlight a bunch of points on this graph, I'll ask you again, like I did before, what's the one thing that those yellow dots all have in common? They all go left 2, meaning every single one of them, if I said name the coordinates of any one of the yellow points, it's left 2, comma, something. To get to any yellow point is -2 something. And that's why the equation of a vertical line looks like this. So that's going to be the new thing for today. Sprinkled in throughout your assignment, there are oblique lines, you know, the ones that go like this and like this, and like this, and like this. There's a lot of those, but there's also going to be interspersed throughout the horizontals and the verticals. You guys got it? Any questions about that? Your assignment is in Delta Math. When you see the number of questions, you might want to say a dirty word. Please refrain. Say it on the inside. It's a lot of practice, okay? But each one, once you get rolling, seriously should take like 10 or 15 seconds. So you'll probably actually get them all done. I'll let you figure out how many problems there are when you look, but don't be surprised if you actually get them done in class today. All right. Did it not assign itself yet? Let me take a look real quick. I must have booped it. Let me pause my recording. I was going to show you guys how to do this. Just a quick tutorial on how to graph in Delta Math. It's super slick. So all I'm going to simply do, if you look like at my equation, where am I going to start my graph? At up to, because this is a normal slope intercept equation. So I'm going to go up to and I'm going to click. Now the next place where I click is going to determine the line. What is the slope of my line? I mean, it's obviously -2, but what does that mean? Don't ever say over, because down 2 over 1, down to right 1, like this. And then you click again, and that's how easy it is to make a line. You just submit it, and that's that. And of course, I wasn't logged in, but you get the idea. How about this one? It says, write the equation of this line. What would the equation of this line be? Nice job, Tegan. X equals -2. And that's actually exactly the same one that was in our notes. And then it says graph the line x equals -5. So if you look up here, and then I'm going to honestly shut up, it says graph the line. You know already, I hope, that that's vertical. It's going to be a long day if you don't. So x equals, I'm going to choose 1. I'm going to choose vertical. And then see how it gives me a line, and I can just pull the line wherever I want to. So since I want it to be at x equals -5, I'm going to go, and if you just get it close, it'll snap it. Whatever you're closest to, it'll snap it to. So if I'm just getting the ballpark of -5, it'll snap to it. And that's that. You guys have any questions at all? All right, cool.